Good morning all, and thanks for joining us for today's training session. We're going to be looking at the FAAC 746 and 844 motors today. We'll get the session done in around half an hour. Today's agenda, what we'll be doing is we'll be looking at the differences between the 746 and the 844 motor. Talking a little bit about starting and running forces. We'll take a short look at the physical installation, talk a little bit around duty cycle, and then we'll move on to the 780D control board connections, parameter programming, and finally the clutch adjustment. And then at the end, we'll have a Q&A. If you do have any questions along the way, just please use your chat window and just bring up any questions. I'll see those and I'll answer them as we go along. You are all muted, incidentally, so I can't hear you. Hopefully you can hear me. So let's look initially at the differences between the two, the 746 and the 844. I pulled up the technical data from each of the product manuals, slightly different formats, but nonetheless, the first thing to look at is the maximum power. The power of the 746 is significantly lower than that of the 844. So the 844 generally is a bigger motor capable of doing heavier gates. The thrust force, in other words, how well the motor pushes or how powerfully the motor pushes. On the 746, you can see 810 newtons, which is effectively 81 kilograms of push force. That's the maximum push, whereas on the 844, you can see 110 kilograms. They talk about decanewtons. The units are a bit confusing, but the gist of it is the 746 can push a maximum of 81 kilos and the 844 a maximum of 110 kilos. And that is always with the Z16, the 16-tooth pinion. The other difference is the maximum leaf weight or maximum gate weight. 746 up to 600 kgs and the 844 up to 1,800 kilos. And then lastly is the startup capacitor. So all of these AC 240 volt AC require a capacitor to get them going, to start them up. And the value of that capacitor is different between the two motors. The 12.5 microfarads on the 746 and 18 microfarads on the 844. All right. The one other difference worth mentioning is there is a 50 millimeter height difference between the two products. So these 6 is 50 millimeters shorter than the 844, and that's largely due to the cover. There's different covers on the units. The actual gearbox, the aluminum gearbox itself, is the same. Okay, let's look at starting and running forces. What do these mean? The maximum force that's required to get a gate moving from rest. So the gate's sitting in the closed or the open position. We try and pull or push on that gate to get it moving. It requires generally more force to get the gate moving than to actually keep it moving. And that's due to something we call static friction or stiction. I suppose you could think of it if you're trying to maybe push a car to get it roll started. It's very difficult to get it moving initially, but once it's moving, it's actually a little bit easier to keep it moving. So the running force is basically the maximum force required to keep the gate running at the rated speed. And these two values are quite important because they will generally indicate, whether a gate motor we're looking at is suitable for that gate or not. And these forces are best measured with a spring balance, which could be typically a fishing scale or a luggage scale. And as you can see in the diagram, this chap trying to pull the gate with his pull scale. So the difference between the start and run force for the two motors, the 746 can start 34 kilos and can run 81 kilos. Whereas the 844 can start 64 kilos and run 110 kilos. And the important thing to notice here is that with these 240 volt AC motors, the starting forces are actually significantly lower than the running forces. And so the starting force is actually the important metric here. In other words, how difficult is it to get the gate started? That's actually more important than how difficult it is to keep the gate running. Because if the motor is incapable of starting the gate, then it's not going to get it even going, so we don't have to worry about the running. So really, it's that initial force. And although we do talk about using the spring balance to measure that, obviously with experience, you'll get a feel for a gate, whether you can get it going, how much it takes to get it going. Do you need to scrum down like a rugby forward to get it moving or not? But the starting force is really the important one to be looking at. In terms of the physical installation of the product, the first thing is obviously this product needs to be fastened down to some sort of foundation. Now, in many cases, there's already an existing concrete pad or concrete plinth. If not, there will be a concrete plinth that needs to be cast. The manuals do cover quite comprehensively the requirements for this foundation plinth, and this is always for the worst case, in other words, for the heaviest, largest gate. So in the manuals, you will find these details. I'm not going to go too much into them, but they do give dimensions of the foundation. They talk about the steel reinforcement that should go into the foundation, etc. And again, as I mentioned, in these cases, this is for the worst possible scenario, the heaviest gate. Okay, the product itself fastens down onto a base plate, which is provided in the kit. The base plate is a metal plate. It's provided with 4 bolts. And the idea here is that you assemble this base plate using the nuts and the bolts provided. You provide a 70-millimeter protrusion underneath the base plate. And the idea here is that those protruding bolts actually get cast into the concrete when you throw the concrete, and that fastens the base plate into place. In most cases, the concrete plinth already exists, and if that's the case, then typically the installer will drill into the concrete in the correct places using the base plate as a template, and then put chemset anchors, sort of anchor studs, into the concrete, fasten them in place, and hold the base plate down that way. And the other alternative, of course, is if you're fastening down to an existing steel structure, then the base plate can actually be welded into place. So essentially, the base plate is cast into the concrete sets. The height adjustment bolt, so there is a bolt that sits underneath the gearbox in 4 points, and the idea there is to actually provide some height adjustment. So we pre-adjust those to 20 millimeters above the base plate, and that provides a little bit of adjustment both down and obviously up. And we drop the gearbox down onto those studs. We place the hold down bolts and washers, which will effectively hold the product down. Before we tighten those, we actually adjust the height adjusters. So we use a spanner to lift or lower the gearbox to ensure, as you can see over here, that we maintain a 3-millimeter gap between the drive pinion and the gear rack. And that'll be throughout the travel of the gate. So that's the purpose of those height adjustments. And once we've completed the height adjustment, we will fasten down the hold down bolts, all 4 of those, which will hold the product down into place. And we will place the cover plates over those bolts, which just makes it cosmetically look a little better. And that's the physical installation. The last thing that needs to be done on the gate itself is the fitting of the gate limit magnets. So in other words, how do we define the open and the closed position of the gate? There is a magnetic sensor on the front of the gearbox, and that detects 2 magnets which are mounted at both the open and the closed position. Now, those of you who are familiar with these magnets will know that there's always one magnet which is marked with a circle and one magnet which is marked with a square. And effectively, that circle and square denote the polarity of the magnet, whether it's a north pole or a south pole. Now, in the 844 and the 746 products, you don't need to worry about the circle or the square. Effectively, the sensors on the 746 and 844 motor are just simply reed switches. They're not fussed about the polarity of the magnet. So circle, square, doesn't really matter. The only important thing is that when you do fasten these magnets in the open and closed position, is that you maintain a 40-millimeter clearance at each end stop. So what we mean by that is when that magnet is detected by the gearbox in either the open or the closed position, you need to be sure that there's at least an additional 40 millimeters of travel available in each direction. And that is just to ensure that when that magnet is detected, there's a possibility the gate might continue to run on for a short distance. We don't want it hitting into the end stop because that potentially creates a situation where the gate can be jammed. So the manual does clearly ask for the 40-millimeter clearance at each end stop. In many cases, you might not allow 40. In the closed position in particular, you may not want a 40-millimeter gap at the closed point. So you can reduce that, but just be mindful of the fact that you do want to allow for some space beyond the travel of the magnet to prevent the gate from jamming up against the end post. All right, so moving on now. The other thing just to mention, two other points I just want to point out. The first is the actual magnet sensor. This is a front view of the gearbox. You can see the drive pinion. This is the magnetic sensor, and you can see on either end of the sensor there's a sort of a small circle which is sort of molded into the sensor. That's actually where the open and the closed limit switches or read switches sit, and that's the point that actually detects the magnet. So that's just more for interest than for anything else. And then lastly, there is a breather screw which is fitted into the front of the gearbox. That breather screw needs to be removed after installation. The point of that breather is that when you remove it, it provides a small hole in the front of the gearbox so that with temperature changes as the gearbox works, as the ambient temperature rises, there will be obviously expansion that takes place inside the gearbox due to that heat, and you want to let that air escape and come back in when it cools down. If that breather screw is left in place, then those pressures that build with heat and cool will or could potentially cause oil leakage, because this unit is oil filled, and the oil is obviously there both as a lubricant and for cooling purposes. So we generally suggest you keep that screw and washer, keep it somewhere on the site in case you ever do need to remove the unit and return it to the factory, perhaps for repair or service, because that will prevent oil from leaking out if the unit is turned over. But it is important to remove that breather screw as the last step of the installation. All right, so what we'll do now is we'll just look at a very quick installation time lapse. These are some chaps in Eastern Europe who are doing an installation. In this case, they've removed an older gate motor. They're replacing it with an 844, and they are welding the base plate down. So what we can do is just for a couple of moments, have a look at the actual installation process. So as you can see here, the base plate is being prepared. The wiring is being put into place. The base plate is put down. The motor is placed on the base plate. The screws are fastened down. In this case, they've allowed no vertical adjustment. They're welding the base plate into place. Putting the covers onto the screws, putting the cover onto the top of the unit. And then as a last step, there's going to be just some final adjustment on one of the limit magnets for the opening position. And yeah, that's a very, very brief overview of that the installation process. Okay, what I want to look at next is understanding duty cycle, what duty cycle actually means. So in essence, there are two, there's sections in both the 746 and the 844 manuals which refer to the duty cycle, and this really talks about how hard the motor can work. The way that the manuals describe duty cycle is slightly different for the 746 than for the 844. In terms of the 746, they talk about a continuous use time, and the specification is 90 minutes of continuous use at 25 degrees C. So what we're basically saying is at an ambient temperature of 25, so it's a mild day, we can actually run that 746 continuously for 90 minutes. So basically open, close, open, close, open, close for an hour and a half before it gets too hot and shuts down. If that ambient temperature was higher, so the case of 55 degrees, now 55 degrees is really hot, but is not uncommon in a, let's say on a warm day, a 35 to 38 degree day in direct sunlight, the unit could easily reach 55 degrees. And in that case, you can only run it for 50 minutes at continuous. So in other words, for just under an hour before the unit will shut down on temperature overload. Incidentally, both of these units, the 844 and the 746, have a thermal shutdown. Once the unit then cools, that thermal shutdown resets and the unit starts to run again. The other specification that 746 talks about is the usage frequency, and basically what they're saying is that you can run it at 70% at 25 degrees C or 50% duty at 55 degrees C. And what that really means is that you can use it continuously at a 70% duty cycle. And what is duty cycle? So to cover that, we will look at the specification for the 844, because the 844 talks about duty cycle and describes it effectively by saying that duty cycle is the sum of the opening and closing times. In other words, how long the gate takes to open and close. Generally, those are the same, incidentally. And they divide that by the sum of the opening time, the closing time, the pause time, which is what we also call the auto close time, and then the wait time. In other words, how long do we wait between operations? We multiply that by 100 and we get a duty cycle. So let's look at it by example, a 6-meter gate with a 25-second pause or auto close time and continuous operation. So that means the gate opens, waits 25 seconds, closes, immediately reopens, waits 25 seconds, closes. The duty cycle is then the opening time and the closing time. So a 6-meter gate, if you do the calculation on the speed of the 844 or the 746, the opening time will be 38 seconds, the closing time will be 38 seconds. We divide that by, again, opening and closing times, 38 and 38, plus the pause time, which is 25 seconds. And the wait time, well, we said there's no wait time. As soon as that gate is closed, we will reopen it again, and we multiply by 100. And that gives us a duty cycle of 75%. So as you can see, that duty cycle can be reduced by increasing the pause time or by increasing the time between cycles. But in the event of this particular duty cycle, which is 75%, we then have this curve, which is called the use frequency graph. And that's again included in the manual for the 844. And if we look at a 75% duty cycle, so the y-axis in this graph is the duty cycle and the x-axis is the amount of time that we can run at that duty cycle. So in this particular example, 75% duty cycle, so you can see we go to 75%, we move across to the graph, and at that point where we intercept the graph, we drop down, and we see it'll be between 0 and 1 hour. It's going to be about half an hour. So on an 844, we can run at 75% duty cycle for half an hour. After half an hour, the unit will get too hot and it will shut down. The important thing to note is that this curve is valid for an ambient temperature of 25 degrees C. So if we happen to be operating in the outback somewhere and it's getting up to 35 or 40 degrees, then that duty cycle is significantly reduced. So the important thing to look at when we talk about duty cycle is to see that the opening and closing times on a gate are fixed. The only thing we really have to play with is the pause time. And so in sites which are going to work very hard, we generally want to try and push that pause time as long as possible. And that will ensure that our duty cycle is as low as possible and we have the lowest possibility of the unit actually going into shutdown. So that's an important factor when choosing that gate motor or when specifying the gate motor, is to look at how many times a day is that gate intended to open and close, because that will prevent any unexpected shutdowns. All right, to the 780D control board now. So this is effectively the controller that you will find in the 746 and the 844. Any of you who worked with this will be very familiar with that layout. What I will do is just show you that in order to access that controller, we need to remove a plastic cover. In many cases on site, I've seen this plastic cover is being discarded. Generally, it's better to leave it in place just to prevent anyone, if they open that unit, from getting their fingers onto the 240 volts sections of the board. This is a schematic of the control board, just basically showing you the various connections, what they do, the various plugs and connectors. And this is, again, all available in the manual. We will start to drill into this control board now and look at the various sections and what they do. So the first thing we'll do is we'll look at the 240 volts and the earth connections. So these are connected to a 3-way connector, which is quite clearly marked as L, which is the active or the live, the neutral, and the product earth, the earth. The important thing here as well is that the earth needs to be bonded locally to the gearbox. There is a bonding stud. So effectively, your incoming earth must also then be bonded to that little lug or stud, because that effectively earths the casing of the gearbox. And if anything does go wrong, you're not going to then risk life. It will be simply tripping the RCD. The other three high voltage elements, or three elements that are important to notice, the transformer for this control board is actually a separate entity. It plugs into the control board and then bolts down onto the gearbox. The second plug is for the motor capacitor, and that plugs again into the control board. The capacitor sits just behind the control board. And then the other pre-configured plug is the limit switch reader, and that's also pre-connected generally to the control board. The other important 240 volt connection, which is on the same plug as the mains, is the actual motor itself. So the motor has 3 wires. Generally in this product, it's a brown, a black, and a blue wire. Those are pre-wired at the factory as motor 2, motor 1 in common. And then we also have a external lamp. This is a flashing lamp that is generally used to indicate that the gate's about to move. And that's connected to, we have a live and a neutral available. It is a maximum of a 60-watt lamp. This is a 240-volt lamp, so just be aware of that. It needs to be 240-volt rated. And a typical example of what you could use there would be the FAAC X LED, which is a 240-volt flashing lamp. It also doubles as a 24-volt warning lamp as well. It's universal, but in this particular case on these products, it would act as a flashing lamp. What is important to note is you need to use a self-flashing lamp. In other words, this output on the control board simply turns on or turns off depending on the state of the gate. It does not flash. It does not turn on and off to flash a light. So it is important to use a self-flashing light, and that's where the X LED is very good, because the X LED, when powered from 240 volts, is in fact self-flashing. Important to note that when the X LED is powered from 24 volts, it's actually not self-flashing. Just something worth bearing in mind. All right, the other connections, we have a radio receiver. We talked about radio receivers in our last training. These are the 5-pin radio receiver modules that are available either in the RC or the SLH type, and they effectively just plug directly onto the control board, onto the 5-way connector. It is important to orient them the correct way around as per the diagram. We then have our external connections, which are typically our triggers, our gate triggers, which are the open A, typically the open A, which is a full opening of the gate, and the open B, which is generally a partial opening. We also have our safety devices. So those are opening and closing PE beams, as well as an emergency stop or a safety edge, sensitive edge. Not very often used, but there are facilities for them. We also have an auxiliary power supply. So this is a 24-volt power supply that can be used to power PE beams, loop detectors, generally other radio receivers, universal radio receivers. The important thing to note, please, is there is a limitation of 500 milliamps on the supply. So there is a limit to what you can power. Effectively, you need to look, if you are going more than just a couple of sets of PE beams, then just be cognizant of the fact that there is that limitation. And then lastly, we have a warning light. This is different to the flashing light we spoke about earlier. This does not switch 240 volts. This switch, it's an open collector, so it switches a negative and is effectively only rated to 100 milliamps at 24 volts. So generally, this would usually be configured to operate a relay, and then the relay will be used to operate perhaps a warning light or traffic lights or whatever you choose to operate on that warning light. We will talk a little bit about the warning light later on in the parameter programming. But something just important to note on the safety inputs in particular. If you have a look at these safety inputs, and these are the 4 that are highlighted in this red square, they're all shown as normally closed contacts, and that's typical of safety devices because we need them to fail in a safe manner. And in order for the product, for the 744, the 846 to work properly from the get-go, we need to ensure that those 4 inputs are linked to negative if they're not being used by other devices. And we always want to be sure that there's 4 LEDs, the safe, the stop, FSW, CL, and FSW OP, which are the 2 opening and closing beams. Those 4 LEDs must always be on when the device is sitting in a rest state. If you break the PE beam, you then expect the light to go off, but under normal standby conditions, those 4 lights need to be on. If they're not, you will not get the control board to operate. So if there are no safeties used on the site, you will need to put wire links between 3 to 4 to 5, 3, 4, 5, 6, and 7 or 8, which are the negatives. Very, very important to note, we get many calls from customers who can't get things going, and it's because they don't have those safeties bridged out. All right, the next thing we can check is the actual limit switch activation. So there are two LEDs that sit below the display. They're marked FC1 and FC2, and that's from the Italian Linea Corsa, which is a limit switch. So limit switch 1 and limit switch 2. And those lights, when the gate is on neither limit switch, in other words, if the gate is in, let's say, the middle of travel, both of those lights should be on. As soon as you run onto one or the other limit switch, then the light will turn off to show that you're on the limit switch. So they work counterintuitive, they work back to front. So in other words, they're off when you're on the limit, but those lights are quite useful to be able to check that your limit switches are working correctly. So once you put your limit switch magnets, you can put the gate into manual mode, run it up, run it open, run it closed, and make sure that each of those limit switch LEDs turns off when on the appropriate limit. That will tell you your limit switches are working and at the correct place. So let's now look at the programming of the parameters. These are programmed using the F, the plus, and the minus keys. So we basically press and hold the F key to get into programming mode, and we use the plus and the minus keys to change the parameter values. And we then use the F to move to the next parameter. And to illustrate that, we will do a short video in a moment. Effectively, there are two types of programming. There's what we call our basic programming, and there's our advanced programming, covered quite extensively in the manual, and we'll go through that in a moment. But first, let's just look at the video. To get into the basic programming, what we'll see is we just simply press the F button on the control board. To get into the advanced programming, we press the F button, and while we're pressing the F, we then press the plus button. So let's have a look at a short which illustrates how to get into programming. Basic programming, we press and hold the F, which will display a parameter, in this case LO. We will release it, and we'll see the parameter value, which in this case is E. You can change that parameter using the plus or the minus. In this case, LO is the logic of the controller, and in this case, you can see it's being changed to A, which is the automatic logic. We then press F to move to the next parameter, which is the pause time for the automatic logic, and so on. So effectively, each time we press the F, we move to our next parameter, and finally, we will arrive at the last parameter, which is ST, which is the status. When we release that, we go back to the gate status, which in this case is 00, which indicates fully closed. And again, that is indicated in the documentation. So let's have a look at some of those parameters. Effectively, we have the very first parameter. Oh, in fact, no, we're going to first look at entering the second level programming, and we're going to do that by pressing the plus. The plus while we're pressing the F. You saw we got the parameter BO, and once again we scroll through all those parameters by simply pressing the F button repeatedly. Each time it takes us to the next parameter, and once again we eventually end up with ST, which is the gate status. And once we reach the gate status, we are out of programming mode. Always important to leave the board in status display, not to leave it somewhere in the middle of programming. Because if anyone does come and press the buttons, then they will disrupt or corrupt the values. So as you can see, we eventually reach the ST and back to 00. So that's those are the basic and the advanced menus. Let's look at those parameters. So the very first of the basic parameters, which is LO, is what we call the operating logic. Operating logic is how the gate behaves. In other words, does it simply press a button to open, press a button to close? Does it automatically close? Do you have to keep a button pressed in order for the gate to run, which is what we call a dead man control? And each of those logics is quite well described in the manual. I've pulled up an example here of the automatic logic. In this case, it basically says this logic only requires the open command to be used. So when the automation is closed, you give an open A command, it'll open the gate. If the gate is waiting to close and you give an open command, it resets the pause time. If the gate is opening, you give an open command, the command is ignored, etc. So the actual logics are described quite well in the manual. Generally, the two logics that are used are the automatic or the semi-automatic. Every now and again, we see customers using some of the others, but those are typically the most commonly used. The next option in basic programming is the pause time. This is how long the gate pauses in the open position before it auto closes in automatic mode only. The default value is 2 minutes, 2.0. This can be adjusted from 0 seconds all the way to 4.1 minutes. So that's just basically, set to whatever suits the customer. The next option is the motor force. This is how hard the motor pushes. The default value here is 50, which is maximum push force. So that means that motor will push as hard as it possibly can, generally left at 50, unless there's a specific reason that you need to reduce it. The last of the basic settings or parameters is the opening direction of the leaf. And this basically determines, or we basically tell the controller, does this gate open towards the right or open towards the left? And this is always as viewed from the release side of the product, in other words, where you manually release it. And the importance over here is that this information it needs to be known so that the control board knows, is the gate open or is the gate closed? So in other words, if you're using auto close, must it be auto closing? If you don't get this right, the gate will actually auto open. So it is important to determine, does the gate open towards the right or the left, and set it appropriately. And the default value is always opens towards the right. We then exit the last option, which is the status, and we come back to the gate status. And as you can see from these values here, 00 means the gate is closed, 03 means the gate is open, 04 means the gate is open, waiting to auto close, etc. So with a bit of practice, you get to know these various status values. Okay, so to go on to the advanced parameters, the first advanced parameter is BO, which is a boost or maximum torque at initial thrust. What this basically means is if you have reduced the motor power for whatever reason, on initial startup, this will deliver full power to the motor to overcome that stiction, which we spoke about earlier. In other words, getting the gate going in the first place. The default value here is yes, the gate will always push at maximum thrust. The next parameter, SR, means slow movement every time power is turned on or restored. The default is no. If this is turned on, every time the power is turned on or cycled, the gate will run slowly the first cycle until it finds the limit. Generally, this is left as no. BR, which is the final braking, what this means is when the gate actually hits that final limit switch at the end of travel, do we want the control board to actually apply a brake to the motor? In other words, to try and get some of the energy out and slow it down. Now, typically the default value here is 0.5, which means that it provides a small amount of back force to the motor, half a second drive. And in some cases, this is actually enough to reverse the motor and actually move it backwards. So typically, I like to set this final braking to 0, unless it's required for some reason. For example, the gate is maybe running down a slope in closing. But generally, I prefer to set that final braking to 0. The next options are fail-safe testing on the opening and closing beams and the safety inputs. Generally, this is not used in Australia. It is a requirement for the European market. Like I say, nobody here really uses that. We can discuss that further if there are any questions around it, but generally, we will leave these both as no. We will not do any fail-safe testing on the safety devices. We can determine whether we want lamp pre-flashing, and this does relate to that 240-volt lamp that we spoke about, where I suggested you could use the X-LED as a 240-volt lamp. And if we set pre-flashing, effectively, this will flash the lamp for 5 seconds on effectively either before opening, before closing, or before opening and closing, depending on the setting of this parameter. The default is no, there is no pre-flashing set. I have a configuration for the warning light. This is the low voltage light that we spoke about, where I indicated that you would typically use a relay to control the light. And this can be set for a number of functions. The default is as an LED function, and that basically just, it's off if the gate is closed, it's on if the gate is opening or open, and it is flashing if the gate is closing. But we can also set this for a courtesy light, so a security light, and that you can set up between 1 second and 4 minutes. You can also set it up to control an electric lock on closing, to control an electric lock on opening and closing, and also to control a traffic light, which will be on when the automation is open or on when the automation is closed. So you could use it to control let's say, a green or a red traffic light. So that is a fairly configurable output. We then can look at the PE beam response. So in other words, if the photo cell is interrupted, do we want to reverse and immediately open the gate? That's the default setting. In fact, the other option is we can actually stop the gate and only get it to reverse when the vehicle leaves the beam. And similarly for the opening photocells, we can set the opening response to either be to stop immediately when someone drives into the opening beam if the gate is opening, and then to reverse immediately if somebody drives into the beam while the gate is opening. So those are effectively beam responses that can be tailored. We can look at the obstacle sensitivity. Now, what this does is it basically allows us to detect if the gate has hit something, and if it has, to reverse the gate while the gate is closing. Now, this utilizes an encoder, which effectively, and I'm showing that with that red arrow, it's a magnet that sits on the motor shaft and rotates, and there's a small sensor on the circuit board that picks up the rotation of that magnet. And if the control board detects a slowing down of the motor due to an obstruction, it will actually stop the motor and reverse it a short distance. The default value is 99, which is the minimum sensitivity. That can be tuned. I generally leave it at 99 because I don't want to get false triggering of this detection, of this obstacle detection. If you set it to 0, 0, it actually turns off obstacle detection completely. Now, the manual recommends not doing this, but there might be cases, particularly on very heavy gates that are running really badly, where you might need to actually set this to 0 to turn off the obstacle detection because you're getting spurious detections of collisions. And the other safeguard we have is actually there is a mechanical clutch on the product, and we're going to touch on that right at the end. And that can often be used as a safeguard against collision if you do, particularly if you do set the encoder sensitivity down to 0. In other words, to disable that the obstacle sensitivity. You can set the deceleration of the motor. So this is basically pre-limit switch deceleration. In other words, before we actually reach the limit switch, you can start to slow the motor down. And post-limit switch is after we've actually hit the limit switch, we continue to slow the motor down further. Once again, I actually prefer to set these values to 0. I find that they can create problems over time. But again, you can set them as suited on the site. The default values are 10 for a pre-limit switch deceleration, which means that for 1 second before the limit switch is detected, the motor will start to slow down. And for 0.2 seconds after detection, it'll continue to slow down. Again, as I say, I generally set these values down to 0. You can then set the partial opening. So if you're going to be using the B input for a pedestrian opening, the default is effectively 0.5 on a scale of 1 to 20. So that's about 25% full opening. You can tweak that to get whatever pedestrian opening you like between effectively 5% and 100% of opening. And the last parameter here is the timeout, and that is how long does the motor continue to run in the event it doesn't reach a limit switch. So let's just say for some reason a limit switch fails. We don't want that motor running continually. So effectively, I generally recommend setting this timeout to the full run time. So if the gate takes, let's say, 30 seconds to open, add 10 seconds to that. So set the run time to 40 seconds. So that gives you enough leeway if the gate is maybe running a little bit slower due to getting a bit stiff or bad weather. But effectively, if something does go wrong, the motor will time out and stop. Be careful of setting this too short. If you set it shorter than the actual runtime of the gate, then you'll have funny operation because the gate won't reach its limit switches. And that runtime can be adjusted between 0 seconds and 4 minutes. The last thing to touch on is the service indicator. Again, very seldom used, but what this does is it allows you to effectively set up a flashing light that will activate for a short period before each operation once a certain number of cycles on the gate has been recorded. So you could, for example, say set it up for 10,000 cycles, and that will be that after 10,000 cycles, before each gate operation, there will be a delay and a light will flash, which will be the service indicator, telling the customer, you better call your service guy because this gate needs a service now. So again, I don't think I've ever seen anyone use this, but it is there if you wish to use it. And then lastly, we go back to gate status, and that again returns the controller back to the default state. You have the option, if you've made changes and you don't know what you've done, you have the option of restoring factory settings on the controller, and there is a procedure for doing that. You basically just need to make sure that the safe input is active and the LED is on. You press and hold down the plus and minus buttons on the controller simultaneously, and then also the F for at least 5 seconds. And when you see T and S alternate on the display, you release the buttons, and that restores all the default values as per the manual. So this is quite useful if you get to a site you don't quite know what someone's been trying to do. It's just an easy way to get back to a known starting point. Okay, lastly, I just want to touch on the clutch adjustment. We spoke about that. So as you can see here in the diagram, there is a spanner that's being used to hold the drive shaft. There are 2 flats on that drive shaft, and there's a screwdriver that's being used to tighten the clutch. Now, clockwise direction makes the clutch stronger, anti-clockwise makes the clutch weaker. This is a mechanical clutch inside the unit, and effectively it defines the maximum push force of the unit. It is important to know that underneath the clutch pin, which is being effectively being turned by that screwdriver, there's a spring. And the product has 2 types of springs available, a weak spring and a strong spring. The units, I think, are typically fitted with the weak spring. So when you get a kit, you'll often find in the accessories, you'll see there's a spare spring. You might wonder and scratch your head and say, what's that for? It will be the alternative spring. If the weak spring is fitted, you'll find the strong spring in the pack. If the strong spring is fitted, you'll find the weak spring in the pack. Weak and strong is, as it says, the weak spring will basically allow you to adjust the clutch more sensitively. If you have a particularly heavy gate, it's running on a slope, and at maximum force on the weak spring, you're still slipping the clutch, you'll need to change over to the strong spring. So you'll withdraw that clutch adjuster, you'll undo it all the way anti-clockwise until you take it out, change the springs and put it back in again. But it is important to, firstly, to do this clutch adjustment process, take the power off the unit, because the last thing you want holding that drive shaft with the spanner is for someone to activate the gate. And the second thing is to effectively tighten it to a point that provides you with the clutch, or basically allows the clutch to slip at an appropriate force value. So you would run the gate. If the clutch is too loose, you'll find the gate won't run. If the clutch is too tight and you push against the gate, you won't be able to stop it. So you want to effectively get it to a point where it provides the desired amount of force, and maybe then just add a little bit additional force just to allow for some wear over time. So what I will do is I'll show you a very brief video here, which will indicate this chap actually adjusting the clutch. In this case, he adjusts it to maximum. And please note, he's got power on the unit, which, as I've suggested, you don't do. So what he's going to do is he's going to use his 17 spanner to hold the drive shaft. He's going to take his screwdriver and he's going to turn the clutch adjuster clockwise. And in this case, he's turning it all the way until it doesn't go any further, and that will be maximum force on the unit. So in that position, you will not be able to stop that gate. As I say, what I would suggest doing is backing that clutch off, running the gate, pushing against it, finding a suitable push force, and then just maybe adding a quarter turn or a half turn to ensure that you've got a little bit of leeway. So in effect, that will be the last stage, your clutch adjustment. You would run your gate, you would make sure that everything's working correctly, and that will be effectively your installation completed. And here's your gate running. Note I'm showing this at 8 times actual speed, and everything is fully functional. So that covers effectively everything on the 746844 that I wanted to cover. I do apologize, we ran a little bit over time, but certainly we do have a chance for questions now if you have any. So if you do have any questions, what I'd like you to do, if possible, would be to put them into the chat window. Alternatively, what I am going to be doing now is I will be unmuting everybody. So if you do have any questions, you can shout them out to me now, or alternatively, as I say, use the chat box.
Thank you, Ross. That was another great training session.
No problem. Thanks, Oliver. I'm glad you enjoyed it. Hopefully you learned something.
Yeah, definitely. Thank you.
All the existing motors we've come across are an Allen key on the clutch. Are they changing to a screw?
Sorry, could you just repeat that? You said that you've seen, all the motors you've seen have been an Allen key clutch.
Oh, the mic must be on. Yeah, sorry, I didn't think the mic was on. Is the mic on at the moment, is it?
Yeah, I've unmuted everyone, so I can hear you. So,
oh, okay. I was just wondering, because all of the 844 motors that I've come across, the clutch adjustment is an Allen key, not a screw. I wondered, is that changing, or is that just a general thing? Some of them are screw, some of them are Allen key, but all the Australian ones we've come across have been Allen key.
That's quite interesting, because I must say, look, I've only been working on the FAAC side for 2 years now, but I've never come across an Allen key. I've only seen the ones with a flat slot for a flat screwdriver.
Yeah, no, most of the ones I've come across are Allen key.
Okay, well, that might be something that has been changed maybe a couple of years ago, but regardless, the process will be the same.
Yeah.
Will this be available for download later on, Ian?
Sorry, I didn't get that.
Will this be available for download later on?
Yeah, correct. It will be. So just for those of you who have asked, and I've had a couple of questions, last week's session, which was the remote controls, we had some sound issues on our videos. So I've changed the format now to rather caption the videos rather than put sound in. And so this will be available very shortly. The recording will be available online. And the remote control session in the next week or so, we'll redo that and have it online as well.
Will that be sent to our email, will it?
There will be a mail shot sent out to everybody, but all the attendees here will certainly have a link sent to you.
Thanks for the session.
Yeah, thank you.
No problem at all, guys. Thanks very much for joining. Any other questions before we close off?
Yeah, sorry, can we have the slides before we have the presentation so we can take note in the slides?
So you would like me to include the PowerPoint basically as a download on the invitation?
Yes. So
Yes, sure.
so we can take note in the same slide.
Yes, certainly you could do that. Were you able to see the slides while I was presenting?
Yes.
Okay, no
Yeah,
problem.
but I can't take notes there. You
Okay,
understand?
no problem. No problem. We can certainly, I will certainly arrange that. So for the next session, I will make the PowerPoint available for download. I will also email it effectively to everybody as well after the session.
Thanks very much.
All right, guys. Well, thanks very much again for your time, and I look forward to seeing you in a fortnight for our next session on the 415.
Fantastic. Thanks, Rose.
Great. Thank you very much. Bye-bye.
See you. Bye.